Okay guys, today we are going to learn about logarithms, and logarithms are really important. Almost any math you do, anything in science or engineering, almost always come down to logarithms and exponentials. Now we've talked about exponential functions. Give me an example of an exponential function. Y is equal to what?
2 to the x.
2 to the x, okay. And what were you saying?
2 times 3 to the x.
Okay, 2 times 3 to the x, right? So that's a good one too. But what you've got to see is this is exponential. And that's very different than y equal x squared. That's what? What would we call that? A quadratic. Okay. And the thing you have to keep track of, you've got to keep track that those are different. And they're very different even though they look the same. How would you compare y equal x squared to y equal 2 to the x? Which one explodes more?
Exponential.
Yeah, the exponential explodes more. And like, just how would you say the curve of the exponential looks? Well, at 0, if I have 2 to the 0, what's 2 to the 0? 1. Okay. And then as it goes this way, it does what? It just dies off very quickly. And as it goes this way, it explodes, right? So that would be an exponential. It explodes, all right? Now what we're going to look at is we're going to look at logarithms. And a logarithm is kind of like the inverse of an exponential. And in fact, the way you can think of a logarithm is a logarithm, not just abbreviate, log is an exponential reflected over the y equal x line, right? And that's kind of like if you think of, like let's think of a quadratic, okay? This is y equal x squared. Same type of thing. What is the reflection of the quadratic? It's the square root, right? And so you would end up with something like this. And so it's kind of like taking this and laying it over y equal x. Well, it's the same thing. So here the logarithm, if this is the point, if the y-intercept is 0, 1, if we reflect that over y equal x, what is the reflection of this point over y equal x? 1, 0, right? Okay. Now is this going to explode or is this going to lay over? Okay, it's going to lay over like that. And then down here, what's it going to do? Instead of approaching the x-axis, it's going to approach the what? The y-axis. And it's going to look like this. So this is y equal 2 to the x, and this is y equal log of x. Okay, and we'll talk a little bit more about what the log function is. But does that make sense? Okay. So in general, for an exponential, this is not always going to be y equal 2 to the x. It's going to be y is equal to some constant a raised to the variable x. And similarly, this is a logarithm. You have y is equal to log, and then some base a of some variable x. A is a what? A what? Yeah, it's a base, but is it a variable or a constant? It's constant. Okay. Yeah, that's all right. Right. We're thinking through it. So you guys just throw something out. Okay. X is the what? Variable. You see, that's the constant. That's the variable. That's the constant. That's the variable. We're going to see how these things are related in a minute. Okay. And what Tanner called this earlier is right. A is the base. Okay, A is called the base, and log is the logarithm. So this is how it works. Okay, if I have log 8 of 1 is equal to 0, if I gave you that,
would the 1 be in parentheses?
it would probably be good to do that because what you have to see is this is not log times 1. It's log, log 8 of 1, right? It's not times 1, it's of 1. So if you wanted to get rid of this, you couldn't divide both sides by log 8, right? You'd have to do something else to get rid of it. But what you have to see is this is the way you undo this. You could say 1, okay? If I just have 1, where does the log 8 go? It goes like this, 8. The 8 goes to the other side, and the 0 goes up. Do you see what just happened? If I want to get rid of the 8, if I want to get rid of the log 8, I'm left with what? 1. Where does 8 go? To the other side. What happens to the 0? It becomes a power.
So that's 1 equals 1.
Well, yeah, so 8 to the 0 is 1. Okay, you see how that works? So this is sort of what you have to see. If I have log A of x is equal to y, okay, this is called log form. And then how do I put that in exponential form? I want to rewrite it without changing it, okay? In log form, I have a what? Log. In log form, I have a log. Now, I want to get rid of the log and put it in exponential form. What am I left with over here? But on this side, what am I left with? X is equal to, Logan, where does the A go?
To the other side.
And what happens to the Y?
It becomes
X is equal to A to the Y. Now, these could be constants, these could be variables, these could be numbers, these could be anything, but this is how you rearrange it, so you kind of have to see that, all right? So let's work a couple of these. Okay, and I want you to go from log form to exponential form. So I have log 2 of 1 over 16 is equal to minus 4. Okay, Kelsey, how would I put that in exponential form?
116
116
equals negative 4.
is equal to what?
Oh, 2 to the negative.
2 raised to the,
Negative.
okay. So now, what is 2 raised to the negative 4? It's 1 over 2 to the 4th, which is 1 over, see, it works, right? Okay, let's do this one. Log 4 of 16 is equal to 2. Okay, Josie, what form is this in?
Log 4.
And I want to go to what?
Exponential.
So what do I write down, Josie?
16 is equal to 4 raised to the 2.
Does that work? It's magic. It works. Okay? Now let's go the other way. Okay,
I was just going to ask you.
Go ahead.
You answered my question.
did I?
I was going to ask you if we were going to go the other way.
Yeah, we're going to go to the other way. Okay. So I have 10 to the 3 is equal to 1,000. Would everybody agree that 10 to the 3 is 1,000?
Yes.
Okay. Now, and what form is this in?
Exponential.
I want to go to what, Mario?
Logarithm.
So what am I going to say? I'm going to say log of, log what?
Log 10 of 1,000.
Log base 10 of 1,000.
Log base 10 of 1,000 equals what?
3.
3. Right? Because if I take the log away, I'm going to be left with 1,000. Right? If I take the log away, I'm left with 1,000. The 10 goes where? To the other side, the 3 goes up. So here, the way you got to look at it is the 3 comes down and the 10 goes to the base on the other side. I think it's easier going the other way, don't you? Okay, so let's practice some of these. a to the 1/2 equals 3. Okay, Jaden, this is in what form?
Exponential.
Okay, and I want to go to which form?
Logarithm.
Okay, so I'm going to have a log. Okay, and Jaden, what is my base going to be?
A.
A. Log A of what?
3.
3 equals what?
1/2.
Does that make sense? Okay. Now, it doesn't really make sense, but it's just I've shown you a rule and you're following the rule, right? You don't yet understand where the rule comes from, but as we start working with this, this will make sense. So right now you just follow the what? You follow the rules, all right? And the rules are pretty clear. Okay, let's see. Braden, I think you're good at these, so I'm going to have you help me with this one. 125 to the 1/3 is equal to 5. Okay, Braden, this is in what form?
Exponential.
And I want to go to what?
Logarithm.
Okay, so what do I do?
Log base 125 of 5 equals 1/3.
They're going to call you Mr. Logarithm before long. Mr. Logarithm. Okay, very good. Okay, now this is a little trick, okay? Like if I ask you to evaluate, like on those, it's kind of like I gave you the answer already because I gave you both sides of the equation. I want you to evaluate log 2 of 64. Now, if I ask you to evaluate that, why is it kind of hard? What do I not have this time? I don't, okay, I don't have y and I don't have what between y and this? Equals. So if you're going to evaluate it, man, I got to set it equal to something. So this is what you do, right? You're given the problem like this, but you've got to set it equal to what? Y is equal to what?
Log 2. Log base 2.
Log base 2 of 64. All right. So you've just got to put the y in there. Now, if I can figure out what y is, if I can solve for y, I'll know what log 2 of 64 is, right? Does that make sense?
Yes.
So now, I need to put this in what form? Okay, Jaden, can you put that in exponential form for me?
Easy.
So it would be 64.
Okay, 64 is equal to, and you're kind of working this way, right? 64 is equal to?
2
2,
to the y.
right. Okay, and you know, Jaden, if it's easier, like you can write it the other way, you know, like you can write it the other way if it makes it easier to see, but I think you were working through it with it being backwards, and so it was a little bit harder. Okay, so now I made some progress. 64 is equal to 2 to the y, and I want to know what y is. Okay, tell me something that I wish. You wish that this was a 2 to the something, right? So 64 is, how can I write 64? 64 is 2 to the what?
To the 6.
Okay, 2 to the 6th. And Mr. Logarithm did that in his head, which is really good. But for people that aren't seeing it, let's go. Count with me.
2,
4,
8,
16, 32, 60.
2 to the 6th. Okay. What made me happy? You went 2, 4 that you always got, but then you went 2, 4, 8. And if you're not careful, you go 2, 4, 6, right? So it's 2, 4, 8. So now what can I say? Y equals 6. Now that's not the answer. What the answer is, log 2 of 64 equals what? 6. So then we get rid of the y. Does that make sense? You put the y in, you solve for y, and then you what?
Put it back in the equation.
Yeah, get rid of the y. Okay? So let's see. Logan, you help me with this one, okay? And again, this is evaluate log 3 of 81. What do you want me to do, Logan?
Set it equal to y.
Okay, y is equal to log 3 of 81. What do you want me to do, Logan?
So it will be 81
81,
is equal to 3 to the y.
3 to the y. Tell me what you wish, Logan.
That 81 was 3 to something.
Okay, so I'm going to have 3 to the something is equal to 3 to the y. 3 to the what is 81?
4.
Do it with me.
3, 6.
No.
9.
Sorry, 9.
9.
27.
8.
Okay.
And you can also think 9 times 9. 9 times 9 is 81. Right? So 3 to the 4. So Logan, what does y equal?
Y equals 4.
Okay, now you put that back here like that. So log 3 of 81 is equal to 4. This kind of makes sense, doesn't it? Okay, now let's keep going. This is a little trickier one. So Tanner, why don't you help me with this? If I say log 4 of n equals 5 halves, and I want to figure out what n is, how am I going to figure out what n is, Tanner?
Setting n equal to 4 to the 5.
You're going to put it in exponential form, right? So you gave me the right answer, but what you were doing, I want everyone to understand, is you're putting it in exponential form. So n is equal to what?
4 to the 5.
4 to the 5 halves. I cannot stop now because I got to figure out what. Tell me how to figure out what 4 to the 5 halves is, Mario. What's like? What could you do?
You could
No.
square root 4.
Yeah, you could square root 4 and then take it to the which power? Okay. What's a different way that you could do it?
4
You
to the 5th.
Take 4 to the 5th and then square root it. Which is the better way to do it?
4 to the 5th.
Square root it first because you'd end up with this big thing that's hard to find the square root of. So this would be 4 to the, this you could think of it as 4 raised to the 1/2 raised to the 5th, right? Power to a power. So that's equal to 2 to the 5th. And what is that equal to? Kelsey, help me. 2 to the 5th. 2.
10. Wait, what?
Okay, we're trying to figure out what 2 to the 5th is by counting. So 2, we multiply by 2 again is, and then,
8, 16, 32,
okay, 2 to the 5th is,
30.
why am I doing that? So you can do them in your head. If you think of it that way, you can count on your fingers and you can multiply, and it's an easy way to get them without a calculator. Levi. Come on, without a calculator. Okay. Let's go. Log 9 of x is equal to 3 halves. Levi, I need to know what x is. What is x?
Log 9.
What?
What is the equation?
Log 9 of x equals 3 halves.
X equals a to 3.
That's 9.
Oh, 9 raised to 3.
Okay, and then how do I deal with the 3 halves, Levi? What do I do?
X equals 1 or 9 raised to the 1/2 raised to 3.
Okay, and 9 to the 1/2 is?
3.
Okay, so this would be like 9 to the 1/2 raised to the 3. So x is equal to 3 raised to the 3, and that's equal to 27. So x equals 27. Does that make sense? Okay. All right. Another little trick that you can do, and this is something, all right, like if you really want to make me yell and scream, you would say that a plus b squared. How would you make me mad?
You said is equal to a plus
A squared plus b squared. That's what? Wrong! Okay, you know how we go over this over and over and over? The square root of a squared plus b squared, what?
does not
Does not
a
equal
plus b.
A plus B, right? So this is one of those, because those two you make over and over and over. Okay, if I have log 2 of A plus log 2 of B, and then I have that's equal to log 2 of C. Okay, you know what people do? They come in and they say, you just drop all the logs off. A plus B equals C. No! No, 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 no. Okay, you can't just drop the logs off. Does that make sense? What can you not do, Levi?
Drop the logs off.
Would you promise me that you'll never drop the logs off?
I can try.
I don't take that as a promise. Yes, Tanner, you are right, and we'll get to that. But you see what the problem is? That's what people do. The one thing you can do, based on what we know now, is if you have log of banana is equal to log of log cabin, if it's log of something equals log of something, in that case, what can I do? Banana equals log cabin.
Or when you're adding something.
Yeah, when it's log of something plus log of something equal log of something, you can't drop them off. But if it's just one log of everything equals one log of everything, then you can take the logs off. Does that make sense? Okay. Are we getting a little storm out there? Whoa.
Yes, it's supposed to rain today.
Yeah.
It's supposed to be getting like severe.
Yeah. Should we practice our tornado drill?
Yeah.
Duck and cover?
We should do that. For
No, that's the
last
fire
3
drill.
Just run outside.
And it's like one is 3 bills and one is 2 bills. And can you imagine that it's a tornado thing and we run outside? 5 bills.
A fire and a tornado at the same time.
What would you do?
Fire.